Hey guys, good morning. We're going to be doing a question on the Ibero-American Olympiad. I think I gave it to you earlier in the week. So the question goes that if you have a number, an integer n, and then the function s of n, which is just the sum of the digits of n, then you have a look at two properties. One is property p, where n, sn, and so forth, s of n, and so forth, are all even. And then property g, which is the same thing except they're all odd. We want to show that for the numbers from n from 0 up to 2018, not including the 2, then there are more n with the property g than with the property p. So I want to start by having a quick look at some examples. So g, choose a pen that works. So let's look at g, right? We just want them all to be odd. So we could just try 1, 3, 5, 7, 9. Now those are all fine because if n of n is the same as s of n, there's no other digits to add up, and so they're all odd anyway. But if we go up, if we try 11, the problem is 1 plus 1 is 2, so that doesn't quite work. But if we try, for example, 21, that does work because 2 plus 1 is 3. Then the same thing again with 23. Then we want to keep going up, and we find that the next ones after the 20s obviously all seem to work. 31 doesn't work because 3 plus 1 is 4. So now we have a look and we find that it's 41 is the next one. So let's look at the same thing with p. Now again we find 2, 4, 6, 8. Now 10 doesn't work because 1 plus 0 is 1. So we can't do that. But 20 does work because 2 plus 0 is 2. And again 22 and so forth up to 28. We can't do 30, but we can do 40. Now, I start to see a bit of a pattern here. Look, there's correspondence between them. Every number has a matching pair, except this number 1. So that's where the key behind this particular solution really goes. So we're going to show nicely that if n has property p, then n plus 1 has property g. And that creates this match, and that match is going to be true for every element except this number 1. So that 1 is going to be in excess because actually normally 0 would be here, right? And 0 would be matched to 1. But since we said n has to be bigger than 0, that reduces this match and actually means that we have an extra 1 over here. So let's have a quick look at how we're going to prove this. So I'm going to take a number n, right? And I'm going to look at its digits expansion. It's going to look like, how we usually do it. aj minus 1, aj minus 2, doesn't look like a1, a0. Right? And remember, that's just the same as the sum of 10 from I equals 0 up to j, or 10 to the j, aj. And now this number n has property p, right? So therefore it has to be even, right? Which means that a0 is equal to 0, 2, 4, 6, or 8. Okay? Now if we look at n plus 1, well that's just this whole number plus 1. aj, but plus 1. Now, if we want to write the same digit expansion now, but instead of n plus 1, it's quite simple. All we actually always need to do is just add 1 to the last digit. So this new number is now odd, and the last digit is just 1, 3, 5, 7, or 9. We don't need to change any of the previous digits because we're just adding 1 and it's already an even number. So then the sum of the digits of s of n plus 1 equals the sum of the digits of n plus 1, because we just added 1 to the last digit and kept all the other digits the same. Fine? So now what we're going to have to do is, when we have this nice property over here, is we have again that n is property p, right? That means that n, s of n, are all even, right? But we know now that n plus 1 is obviously odd. That's clear because n is even. Now s of n plus 1 is the same as s of n plus 1, which we know is now odd because s of n is even. And again, if we look at s of n plus 1, well that is just s of n plus 1 right? And this then is just S. So we can just remove that 1 again. This is just S of S of n plus 1. And again, that's even. So the whole thing is now odd. And so we end up seeing that actually every single term in the new sequence is now odd. So now we see that if n is in property P, then all of those terms are even, but then all of the terms in for n plus 1 are now odd. So therefore n plus 1 has property G. And then we see we can just apply this match, and so for every number in property P, we have a number in property G, except one extra in property G, which therefore means that we have more numbers in property G than property P, which is what we wanted to show. Make sense? If you have any questions, let me know. Bye guys.